Hi guys, this is Arvin Vohra, founder of Vohra Method, and this training program is for new teachers to talk about how we use the Vohra Method to help students actually build rock-solid skills in math, in reading, and in other subjects. In the book Zen and the Art of Motorcycle Maintenance, the author talks about the following situation. You're fixing a motorcycle and you accidentally shear the head off of a screw. Now, the difficulty is you need to unscrew this particular screw, but you can't because there's no slot to put the screwdriver in. So you're stuck. And you're not just stuck, you're infuriated. Why are you infuriated? Because you've been defeated by this 5-cent screw. You can buy 30 of these for $1. It's so minor, it's so insignificant. The idea of being completely set back by something that's just this 2-cent piece of garbage, it's maddening, it's infuriating. And what he says you'll do in this circumstance, first you're going to yell and swear, maybe throw a few things, step away from it, and eventually, over the next few hours, the next few days, maybe the next few weeks, this important change happens in your mind. And you start to realize something important about this particular screw that you're dealing with. This particular screw isn't worth just 5 cents. This particular screw is currently worth the entire selling price of the motorcycle. If that's a $5,000 motorcycle, this little screw is currently worth $5,000. And if you reevaluate this screw with this perspective, if you stop thinking this is a 5-cent nonsense, I don't care about it, to saying this 5-cent screw is worth the entire selling price of this motorcycle, now you're willing to give it $5,000 worth of attention and importance. You're willing to research, you're willing to learn about different methods to deal with it because you see how significant and how important it is. The biggest mistake that math teachers make in the whole world is partial credit, because what they do is they say this little thing is not that important. Yes, not knowing this little thing made you get the entire math problem wrong. You got the whole thing wrong. Your answer is literally wrong, but it's so small that we're not going to count it. And doing that, giving that perspective gives people a huge disservice. Because if you don't get those little pieces right, then the whole thing is going to be wrong. What we do at Vohra Method is very much the opposite. We give the little tiny pieces all the attention that schools refuse to give them. A school will say, my God, how ridiculous would it be to spend 45 minutes discussing a negative sign with a student? In reality, they should be ready to spend 2 or 3 months because maybe the student just doesn't know the difference between how to write a negative sign or a plus sign, but chances are there's probably something underlying there. There's probably something deep-seated that this tiny little, what they're calling insignificant issue is doing. This tiny insignificant thing is actually not at all insignificant. It's actually quite important. So how does that translate into teaching? I'm going to give you an example over here. Here's a problem I made up. Fred buys some dogs and cows. The dogs cost $3 each, and the cows cost $4 each. The total number of animals is 11. The total costs 39. How many of each animal are there? And most of you can probably do this problem pretty easily. You give this problem to a student, and the first thing the student's going to say is, I don't know what to do. I don't know. And so you think, okay, well, maybe I'll start setting it up. You might say, oh, go ahead and just write something like this. Let D equal number of dogs. Let C equal number of cows. Then what equation should you use? The student says, I don't know. Oh, well, maybe it's this equation. Then you go ahead and say, like 3C plus 4D equals 39. What's happening here? The student's not learning a single thing. The student is basically probably tuning out. If not consciously, they're not giving it the attention that it deserves. And this type of process, which is what most teachers and most tutors do, they just basically tell the information, guarantees only one thing, which is that the student's never going to learn how to do this. So let me show you how we do this, handle the same problem in Vohra Method. The student says, I don't know. You say, well, do you have any thoughts at all? Do you have any ideas? Maybe the student says, I have no idea. That's good. That's good. If the student has literally no idea what to do here, there could be some deep underlying issues. So we might check some things with basic equations. We might check some things with arithmetic. We might just see what are these underlying skills. If a student looks like this and has no idea how to start, something's missing. That's okay. We're looking for those little things that are missing. It might be something small. It's probably something big. On the other hand, let's say that the student does this. All right. Student says D equals dogs. Now that's sloppy. What does D equal? The temperature of the dog? The height of a dog? What does it mean? Now, of course, if the student means that D equals the number of dogs, the student will eventually say that. But you should not say, you should write D equals the number of dogs. You should say, can you define that better? If D equals, you might say, if D equals 7, what does that mean in your system? You're testing the system, right? It's very different to ask pointed questions than to basically remove the opportunity for the student to ever learn anything. Now, if the student's like D equals dogs, I don't know what else to do, that's fine, because we have a worksheet for that. It's called defining variables or something like that, word problems in defining variables. If you don't know what worksheet to use, you could ask a head instructor. Or you could just maybe even ask a student, if you think it's simple enough, just ask the student a question. Now we go to that worksheet, then we come back here. So now the person says D equals number of dogs, C equals number of cows. Now here they say, I don't know what to do. And at this point, here's where it gets tricky, right? Because now you think they do know what to do. So you're like, well, maybe are they faking it? Maybe you yourself are getting a little frustrated, and you're like, oh my God, we've gotten so close. I'm just going to kind of tap it over the edge. I'm just going to give a little help. Wrong, wrong, wrong. Giving a little help is exactly wrong, because here, if they don't know what to do next, if they don't know to write something like D, something like say D plus C equals 11, if they don't know how to write that, you're actually dealing with something more significant. Here, if a student cannot get to that, and they're not just goofing off, they really can't get to it, here it means that there's a deeper underlying lack of understanding of what a variable is, how to create a mathematical model. And again, that's totally fine. Our job is to find problems and then fix them. If we can't find the problems, we can't fix them. Then we'll just end up doing the same kind of stupid stuff that schools do. If they don't know what to do, first, of course, you ask any ideas. If not, you send them some kind of a worksheet addressing some of the underlying issues. Now, the nice thing you'll notice is that sometimes as soon as the student sees that they're going to get a worksheet instead of an explanation, it'll kick the brain to high gear, and it's like, oh, no, I remember what to do, and they're like, D plus C equals 11. Then from there, maybe they can get this far, but they can't get to the idea that 3D is the price of the total cost of all the dogs. Again, that's good. It's good if they don't know, because our job is to find out what they don't know so we can build it to the next level. Each one of these little steps is as important as that motorcycle screw. Remember that motorcycle screw? This thing that was 5 cents but actually worth the entire selling price of the motorcycle? Each of these little tiny things is worth their entire math ability. It's worth their SAT score. It's worth their AP calculus score. It's worth doing well in college. It's worth, later on, whatever they do. It's worth all of that. It's not insignificant. It's actually very significant. So the idea of being able to say that 3 times D is the total cost of a dog, that's major and significant. We have several worksheets that help with that. Worksheets ranging from things that define what revenue is and help them explore that idea, to worksheets that deal with mathematical modeling, underlying worksheets that deal with multiplying monomials to be comfortable with the algebraic part of it. And that's good. That's what it's supposed to be. We are supposed to be looking for these tiny things and giving them the time. So the question is, well, when do you just give a direct explanation? Very rarely. Almost never. When do you handhold? Never. Here's when you're going to give a direct explanation, when you're teaching very, very basic things, and those will have pre-programmed videos for. So for example, things like long division. We don't expect a student to just figure out how to do it all by themselves, so we have a video that shows them how to do it. 2-digit multiplication, things like that. That's with students who are really don't know a lot of the basics of math, and that's fine. A lot of those videos are peppered into the program automatically anyway. And if you're not sure what to do, just ask a head instructor. But it's almost never going to be the correct thing to just give the explanation. Sometimes you'll say no, sometimes you'll say try again. You can give them the X button that gives them that big red X to let them know that that's not right. You can give them follow-up worksheets. If it seems that whatever they're working on is way too advanced, you can give them a worksheet on just any topic that's more basic. But the key here is don't set it up for them and just have them do some small part, because if you do that, what'll happen is they'll maybe learn how to do that tiny part and be missing 99% of it. So when you have a question, you got to give them time and effort and all that to go through that process. Being able to say that D equals the number of dogs, how much time is that worth? Well, a very large percentage of high school students who've gone through 4 years of high school can't do this. In other words, 4 years is not enough time to learn this. So 5 years, I think, is a perfectly reasonable amount of time to spend to effectively do this. 4 years, if 4 years is enough time to spend to not learn how to do it, I'd say that 5 years is certainly enough time. It's certainly okay to spend 5 years to learn it. So don't think that you need to do this in 30 seconds or 2 minutes or a day or even a week. Sometimes a single skill can take a very long time to build, but when it's actually built and they actually have it, not like they've memorized some stupid formula to forget the next day, they actually have it, now they're learning math or reading or chemistry or history. It doesn't matter what it is. That's how they're actually learning it, not just, memorizing some nonsense, suffering through their test and forgetting it. We're talking about real long-term understanding. Now, I don't think you guys need this reminder, but make sure that if a student struggles with a problem at all, you always add it to the review. If you have questions about this, feel free to discuss it with me or Chelsea. This is the most important of all of your skills as a Vohra method teacher.